Okay, next topic is complex numbers. We define a complex number. This basically has two parts. All right. Let us assume that A, comma B are the two right numbers belonging to R. R is a group, right, which includes all the real numbers. A and B can be real, right? Real numbers are, right, they are fractions, right? They can be integers, whole numbers, they can be positive, they can be negative, right? They can be rational, right, etc. All are coming under this capital R. Okay, now how do you define a complex number? The complex number standard notation will be Z is equal to A. You can have plus, see this is I times B. I is the, where I is equal to root of minus 1. So such numbers, actually if you write A plus IB or even A minus IB, they basically do not exist, right? Because of the imaginary part, right? A and B are real, right? This Z is the complex number. This part is the imaginary part of the number. This A is called as this real part. This Z is called as the complex number. Okay, so we can also define, say, another kind of complex number. Let's say this is uh, Z1 is equal to A plus J times B. Let us say Z2 is equal to C plus J times D, right? So if we say that Z1 equals to Z2, then what does it mean? It means that, right, we can write the real part of Z1 should be equal to the real part of Z2. Okay, what are the real parts? A and C. A should be equal to C. If at all we say they are equal. At the same time, this should match that if I compare the imaginary part of Z1 with the imaginary part of Z2, they also should be equal. That means B should be equal to D. You don't have to write the J because J or I could have baribodamu. Okay. ನಿನ್ನೆ ನಾವು I ಹಾಕಿದ್ವಲ್ಲ, so you can even use I, right? It is I times B or I times D. So I and J can be used to switch between, right, as you want. Okay, so this is how we write, where I or J is equal to, this J is equal to root of minus 1. You don't have to specify this once again anywhere else when we discuss about the complex numbers. Now, what are the algebraic operations allowed? So, the different algebraic operations allowed are something like you can perform the addition. That's right. So addition is allowed, right? We can perform when we have two values z1 and z2. We can perform z1 plus z2. So how the addition takes place? Addition will be right. It's actually the same thing. I have to perform a plus ib plus C plus ID. But you see the answer, A real parts get added up, A plus C will be together, plus C, IB, ID, I is common, I times B plus D. Like this you add, that is the addition of two complex numbers. Then subtraction. This is z1 minus z2, right? Very similar to the previous case. You get a minus c, right? Then we have plus I times b minus d. This will be the answer of subtraction. Then multiplication. The multiplication takes place in the following format. You write z1 into z2, right? We have to write a plus jb into a minus, this is not a minus, this is c minus c plus j d. So multiplication is term by term. Andre a into c is ac. Then a into jd will be plus j times ad. Then jb into c is plus j times, this is bc. Then j into j, see the last term is plus j square into bd, right? So this is, let's simplify, ac plus j times ad plus bc. See, there is a j square. We know that j square is minus 1. So this is minus bd. So ac minus bd is the real part of the answer. See, there is no j associated with this. Plus j times ad minus bc is the imaginary. Okay, so multiplication we can perform in this way. Very similarly, we can even divide. Division. Okay, this is denoted by z1 by z2. So let us see how the division takes place. So division in the sense, this is a plus jb whole divided by c plus jd. Now whenever we are trying to perform the division, always remember, right, we are interested in the denominator, and we always multiply this denominator and divide by the denominator, multiply and divide the denominator, multiply and divide by the whole term by conjugate of denominator. So we need to know that what do you mean by a conjugate. Conjugate in the sense, right? So let's write somewhere here. If say z is equal to say x plus j times y, then conjugate is either z ಹೀಗೆ ಬರೀತಾರೆ ಕೆಲವರು z bar or z star ಅಂತ ಕೂಡ ಬರೀತಾರೆ. Anything is fine, right? You simply change the sign of the imaginary part. Plus ಇದ್ರೆ minus ಮಾಡಬೇಕು. So real term ಹಾಗೆ ಇರುತ್ತೆ, x is as it is, the plus becomes minus j times y. So another example, if say z was m, this is m minus j times n. This implies, in this case, the z star should be equal to the m plus jn. So negative idre positive agutte only for the imaginary part. Okay. Now I should multiply and divide by the conjugate of the denominator. So that is c minus jd divided by c minus jd. Okay. Then you simplify, right? This means, see, the numerator is ac, then a into minus jd minus jad, then plus j times bc, then minus j square into b into d. whole divided by, denominator is simply a plus b into a minus b, so a square, that is c square, minus b square, that is j square d square. So this is equal to, the numerator becomes ac, okay, ac plus JAD plus JBC minus j square is minus 1, so this is minus of minus, plus BD whole divided by c square. There is a minus, then j square is also minus 1, so minus of this minus is plus d square. Okay, so this is equal to, we'll write the real terms together. AC plus BD is a real part, plus J times AD plus BC, imaginary part. Denominator is C square plus D square. So this is the result of division of the two numbers. Okay. Okay, now I want you to solve one very simple problem just to understand the process. Okay, so please calculate I plus 1 divided by I minus 1. What we'll do now, denominator na conjugate in the multiply model, correct? So this is numerator as it is, denominator also as it is, I minus 1, multiply this with, right? The conjugate in the sense imaginary part ಇದೆಯಲ್ಲ ಅದರದ್ದು sign change ಆಗುತ್ತೆ. So this is minus I minus 1 divided by minus I minus 1. So you will multiply in this way. Okay, ಇದೇ ತರ ಮಾಡಿದ್ಯಮ್ಮ. So we'll multiply now. So this means, yeah, now you proceed further and calculate the answer. Okay, now let's do another problem, that is 1 minus I by 1 plus I. What I should perform, I'll write as it is first. 1 minus I, 1 minus I by 1 plus I should multiply and divide by 1 minus I, 1 minus I. ಯಾಕೆಂತಂದ್ರೆ denominators conjugate, right? Denominator 1 plus I ಇದೆ, I have to use 1 minus I. Should multiply and divide by same. Okay, so numerator becomes 1 minus I whole square, correct? 1 minus I into 1 minus I. Denominator is, denominator ಯಾವತ್ತೂ ಕೂಡ a plus b into a minus b ಫಾರ್ಮೆಟ್ ಅಲ್ಲೇ ಇರುತ್ತೆ. So it's always a square minus b square. Okay, a square is 1 square is 1 minus b square is I into I square, correct? This is equal to, in the numerator you can see that it is a minus b whole square formula. So a square is 1 plus b square. So plus, what is b square? B square is I square. I square, then minus 2 times AB, 2 into 1 into I, whole divided by 1. This is minus, I square is minus 1, so plus 1, right? I square is minus 1, akade innondu minus ideyalla, that's why it is plus 1. So numerator becomes 1, I square is minus 1 minus 2I whole divided by, this is 1 plus 1 2. So ಇದು ಎರಡು cancel ಆಗುತ್ತೆ. So I have minus 2I by 2, this 2 cancels with this, so you are left with minus I. Okay, let's do one more exercise very quickly. Want you to solve, this is 1 plus I by 1 minus I. Okay, just now again ಬರ್ದಿ ನಾವು question ಇದೆಯಲ್ಲ ಇದರ inverse ಇದೆ ಇಲ್ಲಿ. Alright, this is 1 plus I by 1 minus I ಬರಿತೀನಿ, and I multiply by the conjugate of the denominator, that is 1 plus I. 1 plus I. This is equal to 1 plus I whole square divided by, this is denominator is always same, a plus b, a minus b format alle barutte, so a square minus b square, 1 minus I square. So numerator is 1 square plus 2 times this number, okay, 2I, this is plus I square whole divided by 1 plus I square is minus 1, so minus of minus is plus. Okay, but sign mistake agittu ansutte in your case. So this is 1 plus 2I minus 1 divided by 2. So this cancels, 2 cancels with this, so you see you have just I. Okay, ಅದೇ 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 ಅಷ್ಟೇ ಅಷ್ಟೇ, ಅದಕ್ಕೆ ಇದಾಗಿತ್ತು, ನೋ ಪ್ರಾಬ್ಲಮ್, ಪ್ರಾಕ್ಟೀಸಿಂದ ಸರಿಯಾಗಿದೆ ಆಯ್ತಾ. ಆಲ್ ರೈಟ್, ಲೆಟ್ಸ್ ಪ್ರೊಸೀಡ್. Now let's look at the conjugate and its properties, right? So conjugate plays an important role in mathematics, so let us consider, right. Now before going to the conjugate and its properties, let's look at the plotting of a real and imaginary numbers to form a complex number, right. The only option we have here is to use two different axes, one axis for the real numbers and the other axis for the imaginary. ಯಾಕೆ ಅಂತಂದ್ರೆ ನಾವು ಈಗ a plus jb ಅಥವಾ a minus jb ಅಂತ ಬಂದ್ರೆ, right, a can be plotted along one axis, the jb requires completely different axis, that's why you are using a different y axis for that. X axis ಅಲ್ಲಿ real numbers ಅನ್ನು ಬರಿತೀನಿ, y axis ಅಲ್ಲಿ will write the imaginary part of the number. For example, let me say I have a number that is, let's say I'll write this is z1 equal to a, right, plus j times b. So that indicates in the real axis I am moving how much, a amount. So ಇಲ್ಲಿ ಬರೆದಿರೋ a ಅನ್ನೋದನ್ನ ನಾನು real axis ಅಲ್ಲಿ measure ಮಾಡ್ತೀನಿ. Okay, and the j times b, right, imaginary indicates it is j, so ನಾನು j ಅನ್ನ separate ಆಗಿ measure ಮಾಡಕ್ಕಾಗಲ್ಲ, but b can be measured, right. So this distance is the b. Okay, now if you take its conjugate, it becomes a minus jb. So where to plot, a should be moving along the same axis, so a ಅನ್ನೋದು ಅಲ್ಲೇ ಬರುತ್ತೆ, but it is not plus jb, it is minus jb. So minus jb ಅನ್ನೋ ಪಾಯಿಂಟ್ ಎಲ್ಲಿ ಬರಬೇಕು, ಇಲ್ಲಿ ಬರಬೇಕು, this is minus jb, right. This will be the minus b. So jb ಬರೆದ್ರು ಅಡ್ಡಿಲ್ಲ, right, jb and jb you can write as per the convenience, ಯಾವುದು ಈಸಿ ಆಗುತ್ತೋ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದಕ್ಕೆ ಅದನ್ನ ಬಳಸಿದ್ರೆ ಆಯ್ತು. So you see this is the z1 conjugate, z1 star, that is equal to a minus jb. Okay, now let us consider a different case where I want to mark my point as, say, z2. Okay, let us say this is the point z2, ನಾನು color change ಮಾಡ್ತೀನಿ. Okay, let us say this is a point that is z2 equal to, say, this is x, right, this is minus x minus number, okay, minus x plus jy. So you can see that whatever you measure along the x axis becomes minus x, ಇಲ್ಲಿ ಬರ್ದಿರೋ minus x ಇಲ್ಲಿ ಬರ್ತದೆ, and as usual the jy comes over here. Where should be the conjugate now? The conjugate should be present, right, in the opposite side of the real axis, that is this point becomes the conjugate. So I will write z2 star is equal to minus x minus jy. So this becomes minus jy for us. So point to remember is this, right? When you take a number and the number is present in the first quadrant, ಇದನ್ನ first quadrant ಅಂತ ಕರಿತೀವಿ, this region, right? If the number is present in the first quadrant, right, its conjugate will be present. You can check where we got the conjugate. Conjugate is here. This is the quadrant number 4, right? Quadrant ಗೆ ಹೇಗೆ number ಕೊಟ್ಟಿದ್ದಾರೆ? Always this is first, this is second, this is the third quadrant and the fourth quadrant, right? In the anti-clockwise direction, we keep assigning the numbers to the quadrant. Okay, so the point to remember, first quadrant ಅಲ್ಲಿ number ತಗೊಂಡ್ರೆ conjugate fourth quadrant ಅಲ್ಲಿ ಬರುತ್ತೆ. At the same time, if you do the reverse, in the sense, let me assume that my number itself is a minus jb. Where is the conjugate? Is this, right? Fourth quadrant aliro number na conjugate always comes in the first quadrant. So first and fourth are conjugates of each other. Similarly, if you take a number which is in the second quadrant, its conjugate comes in the third quadrant. Or you take any number in the third quadrant, right? Its conjugate comes in the second quadrant. So second and third are the conjugates. Okay, right? So that's how we try to represent, right, the given numbers, complex numbers on a graph. Or this is how you plot a number, complex number on a plot. We have to use two different axes. Okay, let's proceeding further. Next, let us try to find the properties. Okay, so we'll use we'll see some of the properties that are widely used and they're very helpful. Okay, so we are writing in terms of complex numbers only. So if z comma z1 and z2 are complex, then the first property says that you have a z, you take its conjugate. So you have a number, take a conjugate and once again conjugate, you come back to the same point, right? Same z. So this can be seen from the graph, right? I had some z, I take its conjugate, once again if you take a conjugate you come back, correct? It's the same number. Z conjugate's conjugate is nothing but z itself. Okay, that is the first property. Then the property number 2 is if you add z plus z conjugate, what do you get, right? For example, ನಂತರ a plus jb ಅಂತ z ಇದೆ, ಅದಕ್ಕೆ ನಾನು z conjugate ಅನ್ನು add ಮಾಡ್ತೀನಿ, which is a minus jb, right? Plus minus cancels, you have 2a, right? But 2a is it's a real quantity, right? I'm going to get 2 times the real part of that number. So a ಅಂತ ಇತ್ತು 2a ಆಗುತ್ತೆ, right? So I can write this is equal to 2 times real part of the z. Real part of z is a, right? 2a ಆಗುತ್ತೆ. Okay, that's the property number 2. Then if you perform z minus z conjugate, right, what do you get? You get 2 times imaginary part of z, that is a plus jb ಇತ್ತು ನನ್ನ ಹತ್ರ. I am going to subtract the conjugate a minus jb. So this is a plus jb minus a plus jb. So a cancel agi jb ಅನ್ನೋದು 2 times. So j times 2b. Correct? So imaginary part comes as 2 times. So j into 2 times the imaginary part of b is our answer. Okay, so that's why I have to write a j here. J add ಮಾಡ್ತೀನಿ. So this is j into 2 times imaginary part of b is the answer. Okay, then let's go to the next one. If you see Right. Now, if we say that z plus z bar equal to 0, if at all we say it's not a property, z plus z bar is not 0, z plus z conjugate is not 0. If we say that z plus z bar equal to 0, okay, I'll write if before this so that it's not a property now. So we'll write if somebody says that z plus z bar is 0, right? This implies take z bar to the other side. So the number should be equal to minus of its conjugate on the other, right? This means, right, z is imaginary. Okay, z is imaginary indicates that you don't have a real part. For example, if I say z is equal to say j times x ಇದೆ ಅನ್ಕೋಣ. See that there is no real part, right? It's only imaginary. Then only you get, let's take the z bar becomes minus jx, right? If you add these two, the answer become equal to 0. So z plus z bar 0 ಆಗಬೇಕು ಅಂತಂದ್ರೆ it has to be only imaginary, no real part. Okay, that's what is this proof, right? This is another property. Similarly, we can write in a different form, that is if the subtraction results in 0. If somebody says that z minus z bar equal to 0, this implies z is equal to its conjugate. Z is equal to z bar. Z equal to z bar ಯಾವಾಗ ಆಗುತ್ತೆ ಅಂತಂದ್ರೆ, right? Anyway, right? If you simply take I times y, conjugate is minus iy. See, they are not equal. So equal ಆಗಬೇಕು ಅಂತಂದ್ರೆ ಈ iy part ಇರಲೇಬಾರದು. Only you should have just a. So z equal to a, real number, its conjugate is also a only, because the sign is changed only if you have a I part ಇಲ್ಲದೆ ಇದ್ರೆ sign change ಮಾಡೋದಕ್ಕೆ ಇಲ್ಲ, correct? So they are same. Z and Z conjugates are same if it contains real numbers only. All right, so let us write that in the following format. So this is equal to z equal to z bar indicates that, right, the given z is a real number. It's not a complex number. All right, okay, then right, we apply the following format. If at all z1 plus or minus z2 whole bar is actually calculated as z1 bar plus or minus z2 bar. Individually you can take the conjugates and add or subtract as per your requirement, right? Plus or minus is the other one. Let us say we have a product z1 into z2 are there, right? This product is there and I want to take the products, whichever answer you get, its conjugate. So how do you write this? This can also be equal to z1 conjugate into z2 conjugate. All right, then let us say the next property is z1 divided by z2. This answers conjugate I want. That means you can simply write it as z1 conjugate divided by z2 conjugate. Then another property, this is I have z, I raise it to the power n, then I take the conjugate. This is same as taking a conjugate and then raising it to that power. And z square whole conjugate is nothing but z conjugate power 2. Okay, so these are the very important properties which we are going to use. All right, let's proceed to the problems based on this. So question number 1 is x minus 3 divided by 3 plus I plus y minus 3 divided by, this is 3 minus I is equal to I, right? Then find x and y. See, this is a equation, right, where all the values are known except x and y. So what they are asking is find the values of x and y. Okay, normally we proceed, right? We take a common denominator. It's so though there is a I, we don't have to worry. ಎಲ್ಲ ಪ್ರಾಬ್ಲಮ್ಸ್ ಕೂಡ ನಾರ್ಮಲ್ ಆಲ್ಜಿಬ್ರಾದಲ್ಲಿ ಹೇಗೆ ಮಾಡ್ತೀವೋ ಅದೇ ತರ ಮಾಡಿದ್ರೆ ಆಯ್ತು. ಓಕೆ, ಇಫ್ ಯು ಹ್ಯಾವ್ ಸಮ್ ಫ್ರಾಕ್ಷನ್ಸ್ ಇನ್ ಆಲ್ಜಿಬ್ರಾ, ಯು ಸಿ ದಟ್ ಏನು ಮಾಡ್ತೀವಿ, ಕಾಮನ್ ಡಿನಾಮಿನೇಟರ್ ತೆಗಿತೀವಿ, ಕರೆಕ್ಟ್ ಅಲ್ಲ? ಸೊ ವೆನ್ ಯು ಟೇಕ್ ಅ ಕಾಮನ್ ಡಿನಾಮಿನೇಟರ್, ದಿಸ್ ಇಸ್ ವಾಟ್ ಯು ಗೆಟ್. ಯು ಹ್ಯಾವ್ ಎಕ್ಸ್ ಮೈನಸ್ 3, right? This 3 minus I gets multiplied with x minus 3, correct? 3 minus I plus there is the term y plus y minus 3. ಒಂದ್ಸಲ ಕ್ವೆಶ್ಚನ್ ಚೆಕ್ ಮಾಡ್ತೀನಿ. x minus 3 by 3 plus I, y minus 3 by 3 minus I equal to, okay, so this is y minus 3, right? ಈ y minus 3 ಗೆ I am multiplying by 3 plus I whole divided by, you have 3 plus I into 3 minus I is equal to I. So once again I have a solution now. The denominator will go to the other side by performing a cross multiplication. Okay, right. I can save some time, directly baribodu. Okay, but initially to practice we'll go slowly. Right, let's multiply. X into 3 is 3x. Okay, then x into minus I is minus x times I. Then minus 3 into 3 is minus 9. Minus of minus is plus 3 into I is 3i. First product plus y into 3 is 3y. Then y into I is plus y times I. Then minus 3 into 3 is minus 9. We have plus minus 3 into 3 is 9, minus 9 minus 3i, right, is equal to, right, I'll move the denominator to the other side and multiply it. So there is already a I, right? We know that this is in the a plus b into a minus b format. So a square is 9, then minus I square is minus 1, so it becomes plus 1. So if you see carefully, plus 3i minus 3i cancels. 3x, 3y, yx, yi minus y minus this. So we have, after cancellation, ಉಳಿದಿರೋದನ್ನು ಬರಿತೀವಿ. So we have, right, let's write the real and imaginary terms separated. Real ಇರೋದನ್ನ ಜೊತೆಗೆ ಬರಿತೀನಿ. So 3x is real. Okay, this is real. So let me highlight what are real and what is imaginary. So real terms I'll highlight using this. So see, this is real. I ಇಲ್ಲದೆ ಇದ್ರೆ real. ಇದು real. This is real. This is real. Okay, whatever I highlighted with green color. I'm writing together. So 3x ಇದೆ, ಇನ್ನೊಂದು 3y ಇದೆ, and we have minus 9 two times. So this is minus 18. This is real term. Real. Now I write the imaginary term. So imaginary in ಹೇಳಿದ ತಕ್ಷಣ you always have the I with you. So plus I into, right? So what are the imaginary terms we have? Let me highlight that. So this is imaginary, this is imaginary. Okay, so that means positive irodu y ide. So this is y minus x, right? Because y is positive, yi plus yi, xi ಅನ್ನೋದು negative ಇದೆ. So I am writing negative after this, equals to right hand side. Right hand side ಅಲ್ಲಿ 9 plus 1, this is 10i. Okay, so 10i can be written as 0 plus I into 10, right? Now you recall, right, we had discussed today equal complex numbers. ಯಾವಾಗ ಎರಡು ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರ್ಸ್ ಅನ್ನ ಈಕ್ವಲ್ ಅಂತ ಹೇಳ್ತೀವಿ ಅಂತ ನಾನು ಒಂದು ಕಂಡೀಷನ್ ಬರ್ತೀನಿ. ಲೆಟ್ಸ್ ಗೋ ಬ್ಯಾಕ್ ಚೆಕ್. Okay. Now, if somebody says that, see, this is the point. Two complex numbers are equal, then their real parts should be equal and their imaginary parts should be equal. ನಮಗೆ ಅದೆರಡನ್ನ equate ಮಾಡೋದಕ್ಕೆ ಆಗಬೇಕು. So I should be able to equate the real numbers. I should be able to equate the imaginary numbers. So you see now, what is the real part? Real part is in this answer. The real part looks like this. This is the real part, and on the right hand side, real part is 0. And this is the imaginary part. It should be able to equate with this. Correct? So if this equation is true, then whatever I'm highlighting, those parts should be equal. So this implies, now you say this is 3x plus 3y minus 18 should be equal to 0. This indicates that 3x plus 3y equals to 18. We can actually cancel 3 from this. That is, x plus y is equal to, cancel 3, equal to 6. Equation number 1. Similarly, equating the imaginary part, I have y minus x is equal to 10, right? So this means I can take x and y to the other side. So x minus y, right? xy ಆ ಕಡೆ ಹೋಗುತ್ತೆ, 10 ಈ ಕಡೆ ಬರುತ್ತೆ. So 10 will come to this side, means it is minus 10. So x minus y is minus 10. So you have equation number 2. We have two equations and we want to solve them. Normal calculation, correct? So this means, let us add 1 and 2. 1 plus 2 gives, when you add 1 and 2, x plus y is 6, right? So when you add, y cancels, 2x is equal to minus 4. 6 minus 10, when you add, minus 4. So x equals to minus 2. So when you put x in one of the equation, let's say x plus y equal to 6 ಅಂತ ಹೇಳಿದ್ದಾರೆ. This implies the y is equal to 6 minus x, correct? So y is equal to 6 minus x is minus 2. So 6 minus minus 2 is 6 plus 2. 6 plus 2 equal to 8. Okay, so we got the answer, right? Saying that x is minus 2 and y is 8. So this is how we solve the answer. Right? Okay. Then going further, okay, this is the question. If z multiplied by root 3 plus I4 by 19 is equal to 1, right? Then find z. Okay, this is the next question. So we are supposed to find a z such a way that when we multiply this z by a complex number, which is root 3 plus I by 4, I4 whole divided by 19, I should get 1. Okay, right? That is the question. So let's solve this. So z is equal to, normally what we do in mathematics, simple algebra, we move the multiplier to the other side, right? That means 19 goes to the top, correct? So this is 19 divided by root 3 plus I into 4. But as soon as I see a division, I should perform root 3 minus I4 should multiply and divided by this root 3 minus I4. Okay, so this is equal to 19 times root 3 minus I4. Idರಲ್ಲಿ multiplication ಏನಿಲ್ಲ. Only the denominator will multiply. So this is root 3 square, which is 3. Root 3 into root 3 is 3. Then minus I into I is I square, which is plus 1. 4 into 4, 16. Right? So 16 plus 3 is 19, cancels with this. So your answer is root 3 minus I4 is the answer. Okay, so that z which gives you 1, right, when you multiply with the given number, right, is this one, that is root 3 minus I into 4. Okay, right, let's go to the next question. Okay, I'll ಇದು homework questions share ಮಾಡ್ತೀನಿ ಆಯ್ತಾ. Similar to this ಇದೆಲ್ಲ ಒಂದೇ ತರ ಇದೆ, right? You can solve them and doubt ಇದ್ರೆ ನಾನು ಅದನ್ನ next class ಅಲ್ಲಿ solve ಮಾಡ್ತೀನಿ. Okay, otherwise we'll move to the next topic.